All right, let's look at number 19.7. It's actually kind of a tricky problem. You have to use inverse signs and things, which is really more a next chapter. I'm not quite sure why they threw it in here, but I mean, you guys have done inverse sign before. It's just a button on your calculator. We'll talk about more what that means later. So yeah, anyway, so let's get going. First off, A says, what is the initial voltage output of the circuit? So the voltage is given by this, 2 to the power, and we have our sine function in the power. So initial means, what is it when t equals 0? They're just trying to get us to look at this really carefully, get a feeling for how this thing changes. So we'll do that. So when t equals 0, you plug in t equals 0 here, and we get sine of negative 3 pi. Okay, so sine of any multiple of pi is 0, right? Because let's look at the unit circle. Always think about the unit circle. Sine is the y value. So here's 0, and here's pi, and here's 2 pi, and here's 3 pi, right? And here's 4 pi, and here's 5 pi. Or we could go negative. Negative 3 pi means going this way, and we have negative pi, negative 2 pi, negative 3 pi, right? We can go either way. One way is positive, one way is negative. Just like, remember we talked about if you're going this way, it's negative direction, like omega would be negative. If you're going this way, it's positive. Anyway, the point is, at this point, there's no height. Sine is 0. So sine, t is 0, that's 0. Sine of negative 3 pi is 0. Times 3 is 0. So we just have a 1. So then the voltage is just equal to 2 to the 1, which is clearly 2. And probably it's 2 volts or something. But okay, yeah, they tell us the voltage in volts, so it would be 2 volts. Okay, so that's pretty easy. There, that's how you write volts. All right, B, is the voltage output ever equal to 0? Can this thing ever be 0? So we have 2 to some power, right? 2 to some power that's complicated, called x, all that stuff is x. 2 to a power can never be 0 unless that power is negative infinity. Okay, so if we look at 2 to the negative infinity, that's the same thing as 1 over 2 to the infinity. 2 to the infinity is basically infinity. Well, it is. It's infinity. So that's 1 over infinity. Now, you can't get to infinity, but 1 over infinity is 1 over a gigantic number, which is practically 0. Right? And the limit as we approach that, we get to 0. So the only way to get 0 is for this thing to be negative infinity. But what's up here can never get to negative infinity. This goes back and forth. Sine goes back and forth between 1 and negative 1. So we don't even get close to negative infinity. So it can't be 0. So you would say 2 to the x cannot be equal to 0. It's impossible. Okay, that's all I need to say. They're just trying to get you to look at the function, which is good. I mean, it's good to look at something and kind of understand how it can go. All right, then they say the function, this is, now they want us to just look at this sinusoidal thing, okay? Because they put this power to 2 to make it kind of complicated, and actually because it could be a real-life application of these things. But now, let's just look at the exponent part and see how, and put that into the standard form for a sinusoidal, and then say what, and then sketch it for t greater than or equal to 0, less than 1. Label the coordinates of the extrema. The extrema are the maximum, the highest it gets, the smallest it gets. So let's look at just that thing there in more detail. That's part C. So we have 3 sine of 5 pi t minus 3 pi plus 1. Well, the amplitude, that's fine, to 3. The average, right, that's the d, that's fine, that's plus 1, that's not going to change. But we got to rewrite this. And if you remember, what you want to do is get the t, normally it's an x, in this case it's a t. We want to get that by itself. So we take out the 5 pi. So that would be 5 pi, then the t's by itself, but then what's this? And we have to multiply it by, or divide it by 5 pi, since now we're going to multiply it by 5 pi. So this would be minus 3 pi over 5 pi. I think that's right. Now always check 5 pi times, that goes in the bottom, we're left with 3 pi, 5 pi. Okay, yep, that's right, always check that. Now we can simplify this. That's 5 pi times t minus the pi's cancel. 3/5. We could write it as 3/5. I like decimals. That's 0.6. Let's just change that to 0.6. T minus 0.6. Okay. Now, we want to write this, the 5 pi, we want to write that as 2 pi over b. That's the standard form, right? So we want our 5 pi to be written like 2 pi over b. So what is b so that that's equal to 5 pi? Then b is going to be our period. So that's our last step here. So let's see, cross multiply b, or just switch them, right? That's always the thing you do, just switch those. So b is 2 pi over 5 pi, which is, pi's cancel, 2/5 is 0.4. So finally, we can write this as 3 sine of 2 pi over b, which is 0.4, times t minus 0.6 plus 1. So our wave has an amplitude of 3, it averages around 1, it's phase shifted at 0.6, it's 0.6 to the right from where it should be, and the period is 0.4, it goes back and forth every 0.4, that point's kind of big there. Every 0.4 seconds it repeats itself. That's the period, that's how long the cycle is. Okay, now they want us to graph this thing. So let's do that. Graphing's kind of fun. So they say graph from 0 to 1, only from 0 to 1. So let's see. So let's call this 1 here, and that would be 0.5. And we know the period's 0.4, right? So we're going to get like 2 cycles in here, because every 0.4 we start the thing over again. So going to 1 is actually a lot of steps. So we should put, it's kind of hard now to put 0.4s in here. Let's see if I can do it right. I got to break this up into 5. Ooh, that's pretty good. So something like that, right? So there's 0.1, so these are all points. Okay, so now I have my axes. Now we want to see. So now what you do is you say the average is 1, so you put a dashed line at 1. Now, I'm going to make my y-axis numbers not as, this is 1 for time. I don't want to go 1 way up here because we got to go to like 3. So I'm going to make my y-axis different units. So let's just go like 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Okay, so we want the average is 1. The amplitude is 3, so it goes down 3 and up 3. So that means it goes all the way down to -2, right? So it goes all the way down to -2 here. -2 and up to 4. So it goes all the way up to 4. So our things can go up and down between there. Let's see, it starts at 0.6. That's where where it's 0, in the middle of it, right? Sine waves always start. They're supposed to start, where normal sine wave starts at 0 and starts going up there. Ours is shifted this way, 0.6. So wherever 0.6 is, it starts going up and down. Okay, so that's the first thing we got to find. So 0.6 is right here. So I'll put a dot, and I'm going to make my thing in blue here. What the heck? So, okay, there it starts. Oh, wait. But 0 is right here. So put the dot in the wrong place. So it starts right here at 0.6. Now I got to fix my axis. It's no good. All right. So that's where it starts going up at 0.6. Now the period is 0.4. So 0.4 earlier, it also starts going up. So it starts going up at 0.6, it also starts going up at 0.2. Okay, so that could equally be, we could put a 0.2 here, and that's always okay. Because this number here, the phase, can always be the number there plus or minus the period or multiples of the period. It's going to be the same thing, it just repeats itself. So this could have been 0.2, perfectly good answer. We could add 0.4 and make it 1, perfectly good answer. Infinite number of answers for the phase shift. Normally we choose the smallest one. So really the best answer there would be 0.2 because that's the first one there where it starts going up. So, okay, anyway, what are we doing here? So we're supposed to be graphing this. Okay, so let's see now. What else are we doing? The period's 0.4. So period of 0.4, which means that halfway in between it's going to hit the axis again. So that's right here. So it goes up to here, halfway in between, goes down to here, and then back to here. And then 0.4, period of 0.4, oh, so at 1, it also hits there. So halfway in between, and so it goes here and goes here. Now we can draw our wave. Goes like this, and like that, like that, like that. It's kind of fun to draw sine waves. Now I can continue this way. That's 0.2. So the period's 0.4, so it's going to get back to here. So it's going to go like this. Right? So half a cycle. Every 0.2 is half a cycle. It starts at 0.2, 0.6. Yeah, so it looks like that. Okay, cool. All right, so now we drew it. Nice, pretty picture for our part C. Okay, now D, calculate the maximum and minimum value output of the circuit. In other words, what is this and what is this? Oh, by the way, they said say what the maximum and minimums are, right? Well, here we have a minimum. It should be halfway between here because the period is 0.4. And this is here is 0.2 where we started it. So that would be halfway down, be 0.1. So that's at 0.1. And this one is 0.1 plus the period. So it's 0.5. That one's 0.1 plus the period, so 0.9. And then up here, the maximum, that's 0.2 plus, and this is 0.4, so that's at 0.3, right? 0.1 away. Takes 0.1 to go up, 0.1 to come back down, 0.1 to go down, 0.1 to go back up. That makes 0.4. So that's a 0.3, and then this one would be a 0.3 plus 0.4, so 0.7. Again, every period we're going to get another peak. Okay, and yeah, that's the sinusoidal function. Now part D says what's the maximum minimum of the voltage output of the circuit. So part D, we want to know, go back to my black pen, we want to know what the 2 to that thing is, right? 2 to our function, 2 to this, 2 to that thing there. So 2, I'm just going to say 2 to our function of time because I don't feel like writing that. So what is the biggest number this gets? The biggest it gets is 4. So the maximum is when it's 4. So 2 to the 4th, which is 2 times 2 is 2 times 2. Wait, 2 times 2 is 4. That's 2 2s times 8, 16. So 2 to the 4th is 16. And the minimum is when this thing is negative 2. It gets all the way down to negative 2. Yep, that's right. Yeah, okay. So minimum is negative 2, so 2 to the negative 2, which is 1 over 2 squared, which is 1/4, which we can write as 0.25. So it goes from 0.25, this thing here, the 2 to the power one, right? This thing here goes from 2, goes from 16 to 0.25, 16 to 4. All right, now that's part D. Now, during the first second, determine when the voltage of their circuit is 10 volts. Okay, it goes from 0.25 to 16, so 0.25 to 16, so somewhere in there it's going to be 10. Again, this is the sinusoidal thing, not the 2 to it, so we got to figure out when it's going to be 10. Okay, so I'm going to save this because I want to keep that, but I'm going to erase all this stuff here so we can do this algebra. Okay, so part E, we want to know when that thing here, this thing here is equal to 10. So, and only now it's equal to 10 infinite amount of times as time goes on, right? It's equal to 10 here and here and here and here and here. But we want to know the first time and the first second is equal to 10. So, because otherwise it could be an infinite number of answers. Okay, so E. We set this thing 2 to the, and I'm going to write it this way because it's better. So 2 to the 3 sine of 2 pi over 0.4 times t minus 0.6 plus 1 equals 10. All right, so we got a bunch of algebra to do. So let's see. First, we got to get this stuff out of there. So the way we do that is we take the log of both sides. And because log of something to a power, we can put the power in front. Right? So if I take the log of this side, I can put the power in front. That way I can get it out of there. So that would be 3 sine, I gotta write that thing all over again. 2 pi over 0.4 times t minus 0.6 plus 1 times all of this times the natural log of 2, right? Natural log of the base power in front equals the natural log of 10. Just take the log of that side. See, we got to put the natural log of 2 in the bottom here. I'm going to just do that right now, save myself some writing. So that's 2 there, so we're going to put it in the bottom on the other side. Now we have this equal to that. What's inside here, so I can take away 1 from that side. So finally I have 3 sine, and I'm going to cheat and write all that stuff like that, equals this minus 1, ln of 10 over ln of 2 minus 1. Divide both sides by 3, so the sine of all that stuff is equal to 1/3 of all that. 1/3 of ln of 10, ln of 2 minus 1. All right, just give us a 3 there. So let's get a decimal for that. It's going to be a horrible number. So what is 1/3 of all that stuff? I got 0.773976. So 0.773976. I want to keep a lot of decimal places because, you know, kind of amazing to do these things. Okay, that's what the sign of that thing is equal to. So we want to know what's in the parentheses. So we take the inverse sine of both sides. Inverse functions cancel out functions. So inverse of sine cancels out the sine, but then we need the inverse sine of this. So if I take the inverse sine of this side, the sine goes away, and I have just left, what's left is in the parentheses. Now I don't need this anymore because I've been writing it all the time. So the parentheses, which I'm going to write now, so that's 2 pi over 0.4 times t minus, it's a bad minus, t minus 0.6, we got rid of the 1 already, equals inverse sine of that, inverse sine of 0.773976. I plug that into my calculator. I make sure I'm in radian mode, because I want to know what angle gives the sine of that. So you make sure you're in radian mode. So let me do that right now. So 0.773976. I'm in radian mode, second sine, so I get inverse sine. I get 0.88509. Let's say 0.8851. That should be close enough. That's 0.8851. Now, this is the tricky part. The sine of this thing gives us that number. So what's in the parentheses can be this number plus 2 pi n. There's an infinite number of things that sine can be, right? It can be this answer plus 2 pi n. So in other words, and this is what we go over next chapter and stuff, so this is kind of the tricky part for this problem. When you put in this thing into your calculator, it gives you one of the possible angles, but we're going in a circle. There can be an infinite number. We can go around and around and around the circle. So we have to add 2 pi n. The book likes to use k there, where n or k, I like using n. So n is 0, could be 0, plus or minus 1, plus or minus 2, plus or minus 3, forever. Okay, it's an integer, the integers. I like n, the book likes k, whatever. Use the one that you like. Okay, so there's an infinite number of ones that can give us that, because we can always, here's the answer, we can go 2 pi, or go negative 2 pi, negative 2 pi. And we'll talk about that later. Okay, so that's what that's equal to. That's what this is equal to. But we want t, so we're not done yet. So let's see. To get t here, we got to multiply by both sides by 0.4 over 2 pi. 0.4 over 2 pi, right? So we multiply that, gets rid of this. Then we have left on this side t minus 0.6 equals, we multiply this by 0.4 over 2 pi, and we get a horrible number. You see what that is. So times 0.4 divided by 2 divided by pi. I get 0.056346. 0.056346. So what's the next number? Oh, it's a 9, so I can make that 47. Should be good enough. That's 0.4 pi, because again, I want to get rid of this. 2 pi over 0.4, multiplied by 0.4 over 2 pi. Yep, that's right. Plus 2 pi n times 0.4 over 2 pi. Well, let's see. The 2 pi's cancel. So that's just 0.4 times n. And we have a 0.6 there. So finally, t is equal to 0.6 plus this. Let's add the 0.6 to this. So that just makes it, do that in my head. 0.6563, let's call that a 5. So it runs off to 5. Right, we just add the 0.6 to there. Plus 0.4 n. Those are all the answers we have. N can be 0, it can be -1, -2. We can take away 0.4 from this. We can add 0.4. Again, multiples of the period, right? Multiples of the period, because every 0.4 seconds it repeats itself, right? So we could see that. We could have seen that coming. All right. So what are we even looking for here? We're looking for when it's equal to 10. So it's going to be 10 at 0.6565 plus every 0.4 seconds, which makes sense because it repeats itself every 0.4 seconds, or minus every 0.4 seconds. All right, in the first second, we get that one. If we add 0.4, it's bigger than a second, right? It's 0.4 plus 0.65, it's over a second. But if we could take away 0.4, and it still works, and it's 0.26536 seconds. So there are 2 times in the first second that it's equal to 10. Right here, so it's going to be equal to 10. Let's see, 0.4, so yeah, anyway, yeah, it's going to be equal to 10 at 0.2565 and at okay, yeah, starts to get crazy. This is a hard problem. This is, it's pretty good. A lot of stuff going on here. It's kind of more for like what we're doing next chapter. It's why I'm doing this now to help you out with it. So hopefully this is all making sense. And we're not even done yet. Okay, now it says, actually, where is my, here they are. Okay, so now it says we're only on part E, and unfortunately it goes to the next page, so we know when in the first second is equal to 10 volts now. And then, let's see, what else here? That was part E. Okay. Now, here is another thing that gets messed up that we did not take into account. Okay, I did not take into account. I'm blaming you, saying we. All right, and we'll do this next chapter. Again, this is really a next chapter problem. So, all right, so this number here, okay, we said that, I said earlier that we can get the 2 pi n, right, because that's our solution. Here is a problem. When you do inverse sine, it only gives you one answer. But actually, there's 2 answers. So we only have one of them, and that's why I was looking at this. Okay, when is it 10 in the first second? Well, it's going to be 10 somewhere like, you know, maybe right here. But it's going to be there. There should be 4 times, because we have, right, we get 2 big peaks in there. So it should be, we only got 2 of them, like I said, at 0.65665 minus 0.4, so 0.25635. But where are the other 2 solutions? And here's the problem. When you take the inverse sine, it gave us, my calculator spit out 0.8851. So let's look at that. And then I said, okay, but plus 2 point n, and that's all right. I don't need this anymore. So, but here's the thing. Remember, sine is the y value. So when is the y value 0.8851? So let's look at our circle. So 0.8851 is somewhere like this, right? There's 1. So when is the y value that? Well, what I took was this. And when the y value is that angle right there. and that angle in radians is 0.8851. Okay, so that's what we use. However, there's also this angle over here, right? There's 2 times when the sine is 0.8851. Your calculator only gives you one of them because to be a function, for inverse sine to be a function, it can only give you one answer. But we know that, okay, really there's another answer. There's this one over here. So whenever you take the inverse sine, you add 2 pi n, that's one tricky part, and then you have to look for the other answer. So the other answer is this angle here, which is what? Pi over 2, or pi minus 0.8851. So that's 0.8851 there, right? This is symmetrical there. So this angle is 0.8851, that angle is 0.8851. So this angle here is pi all the way to here minus 0.8851. So we got to do this again. So really, okay, I'm going to write this out now. So we have to do this thing twice, and so I have to say that it could also be equal to pi minus 0.8851 plus 2 pi n. The 2 pi n stays the same. So what is pi minus 0.8851? So I'm going to do that. So pi minus 0.8851. I get 2.2565. 2.2565. So that's equal to 2.2565. That's our other one that works. Now, we do all the same stuff. We have to multiply, divide it by, multiply by 0.4 over 2 pi. This is all going to be the same. We're going to get plus 0.4n. Okay? We're going to get that when we do it, but we got to do all that to here. So I got to multiply that by 0.4 over 2 pi, and then subtract 0.6 from it like I did before. This is getting crazy. So I shouldn't have gotten rid of it. 2.2565 times 0.4 divided by 2 divided by pi, and then you add 0.6, so plus 0.6, and I get 0.74365. So we get t then can be 0.74365 plus 0.4n. Okay, so how many numbers are in there? Well, we got this one, and we can't add it, but we can take away 0.4. So we can get t equals 0.74365 plus t is take away 0.4, it'd be 0.34365. So those are our 2 answers within a second. And over here again, it'd be 0.65635, and then minus 0.4, so 0.25635. Those are our 4 answers where it's 10, which makes sense. 1, 2, 3, 4. Phew, craziness. I should have just saved this for next chapter, and this is going to be a long video, so hopefully you're still with me here. It's a good problem, but okay, that's one more here. Now they say, no, sorry, 2 more. I forgot. I'm still on E here. Okay, F, a picture of the graph. Label the coordinates of the extrema on the graph. Okay, now they show a picture of what, remember this is the sinusoidal part. If we raise 2 to this power, we get the actual picture of the graph. So I'm going to put their picture up here. I think I still left this on. I tried to prepare for this, but I've been talking so long that the projector went off automatically. But I have no fear, I can turn it back on. Okay, so we're going to look at their picture, and we can label what the coordinates of the extrema, which we know what they're going to be. When this is the biggest, this is going to be the biggest. When this is the smallest, that's going to be the smallest. Makes sense, right? So that's easy. But it's kind of fun to look at their graph. Okay, it's not that much fun. It's a little bit of fun. So here comes, I think did my computer go off too? Nope, it's still on. That was a long time. Come on, projector. You got this. Oh, here comes. Yeah. Okay, so that'll be easy. Then part G says, restrict the function to between point 1 and point 2. Explain why this function has an inverse and find the formula for the inverse rule. Okay, this is why it's good to look at this picture here. And I don't need this stuff here anymore. We have our answers. So I'm going to erase all this so we can actually see the picture. Okay, so label the extrema. Well, we know it's at 0.3, right? At 0.3 is where it's at the top. And we know that it gets up to 16. So here's 15, so this is 16 here. So it's 0.3 comma 16. Extrema means the biggest and the smallest, right, within the first second. So this one is 0.7, 16. And then we know the smallest it gets was 0.4. -2, which is 1/4, 0.25. That's right, so this goes down to 1, which looks about right. Here's 2.5, so that goes down to 1/4. So like that point is 0.1, -0.1, and then 1/4. So 0.25, and then we add 0.4, so this is 0.5, 0.25, and then this one is add 0.4. This is 0.9. So that point there is 0.9, 0.25. Right, as always, the smallest it gets is 1/4, biggest it gets is 16. It happens every 0.4 seconds is the period. You get one, you get all the other ones. You can go on forever. We know what everyone is now, right? Just keep adding 0.4. We know the first one's at 0.3, so add 0.4, add 0.4 forever. Okay, that was F. Hooray. Now G. Restrict the function to the domain t greater than or equal to 0.1. Explain why the function is inverse. Okay, between 0.1 and 0.3. 0.1 is here, 0.3 is there. This has an inverse because notice it's this part here. There's no double. If we do the horizontal line test, it only hits that once. See, it hits here, but if we restrict it to here, the line, a horizontal line only hits it once. And remember, that was the test to be a function. It only hits it once. Okay, so that's what they say, explain why it's a function. So we did that. Survives the horizontal line test. Now, find the function. Find the inverse rule. So in other words, we want to know what t is. We got to solve for t. Only for right there. Now we could write, well, yeah, we want to solve for t in there. And they give, and if you look in the back of the book, they give the entire thing, which I guess we have to also here. So here we solve for t, but not generally. We solved it when it was equal to 10. Now they say just, look, what's the general formula for doing that? So we got to do all that all over again. So that's okay. We can do it. We can do it. So that's what we got to do. So we'll do it once here. Then they say for another range, but I think if we do it once, it'll be okay. So, there's a crazy problem. I want to keep that because that's a cool looking graph. So I'm going to erase this part, and let's see if I can write down low here and figure this out. Oh my gosh. Okay. So I'll start here. So our original formula is that. Let's call this y, because who wants to write via t all the time? So call that y. So we have y is equal to 2 to all this stuff. Okay, first step, we take the log of both sides. So ln of y equals all this stuff times the ln of 2. Right, same as we did before. Take the ln of both sides, the parentheses come in front. Still ln of 2, but you can put the parentheses in front. Let's see, we want to solve for this. So we divide by ln of 2. So ln of y divided by ln of 2. Now I need to start writing what's in the parentheses. That's our 3 sine of 5 pi t minus, I'm going back to the original one because it's right there, plus 1. Okay, put the 1 over there, divide it by 3. So I'm going to say 1/3 ln of y divided by ln of 2. Okay, so, oh, and then first you got to take away the 1. Then you can divide by 3. So minus 1. So I put this plus 1, minus 1, and then multiply it by 1/3 to get rid of that. So with this 1/3 and the minus 1, that's equal to sine of 5 pi t minus 3 pi. Okay. Now we take the inverse sine of both sides. Inverse sine of both sides. So Oh, and this very beginning part, we have to decide which one do we take, the positive one or the negative one. That's going to be the tricky part. So anyway, let's take the inverse sine of both sides. So I get finally 5 pi t minus 3 pi is equal to sine -1. Sine -1 can also be written arc sine. It's probably a better way to write it because it's really not 1 over sine. Right? 1 over sine is cosecant. This is not cosecant. This is the inverse. Completely different thing. It's bad notation. Okay, is equal to inverse sine of all this stuff of 1/3 of ln of y divided by ln of 2 minus 1. Okay, plus 2 pi n. Okay, and so finally let's add 3 pi. So 5 pi t equals all that stuff plus 3 pi. Or t, then we divide everything by 5 pi. So t is, oh my gosh, I gotta divide all this stuff by 5 pi. So is 1 over 5 pi sine, inverse sine of 1/3 ln, I always make my L's do ln, I make an H, ln of y divided by ln 2 minus 1 plus 1 over 5 pi times that, plus 1 over 5 pi, right, I divide 5 pi times this 2 pi n plus 3 pi, so 2 pi n plus 3 pi, running out of room. Okay, this can be simplified. The pi's cancel, and we have 1/5, so that's 0.2 times 2n plus pi, or 0.4n plus 0.2 pi. Okay, now they want that to be the very beginning of the thing. So we just choose n equals 0, and it should be pretty good. So it'd be 0.2 pi. So that's, we just choose n equals 0. So it's basically this, what I wrote, plus 0.2 pi. They wrote it a little bit differently in the book. The different n values correspond to the different ranges. And if we want to get every range possible, we also have to do, like I did before, that this could be 2 different answers. No, actually, wait, no we don't, because that's included in here. Okay, so then we just choose the different n values to different places that we want this. So, yeah, it's kind of crazy here. So, but that's good enough. That gives the idea. Again, we're going to get into more of this stuff next chapter, so hopefully it makes more sense. So, hope you could follow all that kind of crazy stuff. Yeah, hopefully it wasn't too bad. Okay, thanks for listening. Really, thank you for listening. You followed me all the way here. Good job to you. All right, we'll talk to you later.